This is Unit 9, Section 9.2, Graphing from Standard Form. So this is the second day in our Graphing Quadratics unit. So last time we introduced some basic characteristics of our graph. We talked about how it opens either up or down, making it a max or a minimum. We talked about identifying the axis of symmetry, which helps us find the vertex. So those key characteristics are going to help us actually put this on the graph and graph them today. And so the first, again, I just have that slide on there to remind us that this is an important unit. All right, so on 9.2, now we're going to start graphing it. So when we look at graphing, we want our quadratics to be in standard form of a quadratic. And so what makes a quadratic is that x squared here. And so what we're going to look at is that U-shaped parabola that's going to help us kind of tell where these points are. If I have an x, what's the y? So if I plug in 2, what do I get for my output? Inputs, outputs. So step 1 is to find that axis of symmetry. And so remember from last time, we had x equals opposite of b over 2a. So it's important that we're in standard form, ax squared plus bx plus c, to correctly identify the parts here. Then find the vertex. So plug x into equation to get y. All right, so that will give us a vertex that has an x and a y value. Fill in a table of values by substituting the x into the equation. And so I'll show you a way that we can plug that in and generate this table quickly. Then plot the points and then connect the points into a smooth parabola. U-shape, I always have to remind us, U-shape, this is not a V. So kind of keep that in mind. So again, have your calculator either out or pulled up so that we can look at that as well. All right, so here's our most basic quadratic that we can graph. It is y equals x squared. So looking at standard form, this would be plus 0x plus 0. So the only thing that it has here is the quadratic form. In fact, they call this the parent function because all other quadratics kind of mirror what this one's doing. Okay, so let's fill out the things that we did last time before we get into our graphing. First, we look at A is positive, so that opens up, making it a minimum. Axis of symmetry, we can do x equals opposite of b, so that's 0, over 2 times 1. Well, 0 divided amongst two things is still 0. So my axis of symmetry, oops, sorry, I got excited on my ordered pair there. So my axis of symmetry is at x equals 0. So my vertex, I'm going to plug in y equals, replace x with 0, 0 squared, I get 0, 0. And so this kind of starts our graphing. So this is from what we did on 9.1. We want to continue that and actually plot these points. What does this look like? So I'm going to put my vertex in the middle as x is 0, y is 0. So this is my vertex. And then I'm going to plot that. Here's 0, 0, right on the graph here. I know that it opens up, so it's going to come up this direction. So there won't be anything down here on my graph. So how do we generate these other points? So what we're going to do is we're going to go above 0, so maybe 1 and 2, and below 0, -1 and -2. This one is not so hard to plug in. If I picked these, you pick, okay, and then these plug in. This is what we have to figure out, what input gives us what output. So on here, now we would go and look at, okay, plug in 1. Well, 1 squared would give me 1. Plug in 2. 2 squared, 2 times 2 gives me 4. Plug in -1. Negative times a negative is positive. 1 times 1, 1. -2 times -2 is positive 4. Notice that there's some symmetry going on, that these match and that these match. So really, I only had to plug in the positive numbers to figure this out. So I can plot these on my graph now. I have x1, here's my x direction, here's my y direction. So I'm going to go over 1, up 1, and mirror it. That's what this axis of symmetry is telling us. And then I'm going to go over 2, up 4. 1, 2, 3, 4. And mirror it. So once I connect in my drawing here, here's my U-shaped parabola. There are other points that are on this, but we don't have a chart further, and we don't have our graph here. So when I'm going to now pull up my calculator and show you, this is the same calculator that we can pull up online too. So I want to show you how you can generate that table like we did with factoring in order to find these points without plugging them in over and over again. Okay. All right, so just like we did with factoring, we're going to, oh boy, maybe I don't have an access code. Okay, I'm just going to pull up our calculator. I thought I had one fancier pulled up. We don't need no fancy thing. We'll just use this one. All right, so I'll pull this one up. And so what this is going to do is I'm going to go, I want to generate a table. So I'm going to go table, and it's telling us what function do you want. We're going to use our variable x, and then we're going to say x squared. That's what's corresponding to our y value and our function here. We want y equals x squared. Then I'm going to hit enter, and I'm going to say where do I want to start and how do I want to step. So you can start at 0 because our graph was starting at 0, 0. I'll show you on the next one that we change this number based on where our axis is. So this says, okay, we can start and step by ones and it will auto-generate it for us, or we can start at 0, step by 1, and I could actually say, just ask me what x's I want. Either way would be fine here. I'll show you both ways. So I hit OK, and notice that it gives me 0, 0, it gives me 1, 1, and it gives me 2, 4. If I go to -1, it gives me an output of 1, -2 gives me an output of 4. It will generate that table for you. So it'll help you make this faster. All right, so let's see this on another one. Okay, now we have a quadratic that is y equals x squared plus 2x plus 1. I like to put my a in here. I can still see that that's positive, so it's going to open up, giving me a minimum. Axis of symmetry, we need to find x equals opposite of b over 2a. Okay, so -2 divided by 2 is -1. And then plug in. So y is going to equal -1 squared plus 2 times -1 plus 1. All right, so I'm going to use my calculator for that. Plugging this in, so I'll clear this out. And we'll go parentheses. Anytime I have a replacement, I'm going to put it in parentheses. 2 parentheses -1 plus 1. All right, so I'm at 0 for y here. So my ordered pair vertex is at -1, 0. Again, this is where I'm going to put that vertex here in the middle. So there's my vertex, and then I plot it. -1, up 0. Here's my x, here's my y. All right, so now I'm going to go back to my calculator, and I'm going to let it generate. I'm going to go 0, 1, -2, -3. So I'm just creating that chart, increasing by 1, decreasing by 1 on either side. These numbers will match, and so will these numbers because of that symmetry we say we have here over -1. All right, so on my calculator, I'm going to go to table, clear that out. I'm going to go with my new function, x squared plus 2x plus 1. Woo! You guys, I missed an x here. All right, I'm going to try again. 2x, make sure you're writing that in, unlike I did. And then I'm going to say table. I meant to say enter. Good grief. I'll get there. enter. Now I want to start it at that -1. That's where my symmetry is. And I still have it auto-generating here, but it gives me -1, 0, 0, 1. So now I can fill this one in, and then it'll give me 1, 4. So now I can fill this one in. It should match. So I'm going to check this, but it should be a 1 here and a 4 here. Let's make sure our calculator did the same thing for us here. So -1 we had at 0. If I go up, -2 is at 1. -3 is at 4. That's that symmetry taking place over the -1. Now I can plot these. 0, 1, and symmetry. 1, 4, 1, 2, 3, 4, and symmetry. It's going to be on the other side. And draw in our U-shaped graph. All right, so our new parts today are these two things, being able to generate our table and being able to plot those points in our U-shaped graph. It opens up, it has a low point here. We have this axis of symmetry kind of acting as this folding line that mirrors over it. And the turning point here is at -1, 0. All those things that we practiced last time are coming into play here. All right, number 3. All right, so now we have y equals -x squared minus 8x minus 17. I'm going to put my 1 in there and notice that it's a -1. So now our graph is going to open down, giving us a high point, a maximum. X equals, I need to calculate that, opposite of b. Opposite of -8 is +8 over 2 times -1. 8 divided by -2 is -4. Okay, so here's my axis of symmetry. And then plug in to find y. Plug in -4 for x, minus 8, plug in -4 for x, minus 17. All right, so in my calculator, I'm going to clear this guy out, and we're going to go negative, parentheses, replace x with -4, squared, minus 8, parentheses, replace x with -4, and minus 17. All right, so that's -1. So here's another thing that we can do here. If I wanted to, okay, I can go to my table and enter this in. So I'm going to have -x squared minus 8x minus 17. Got it right that first time. Hit enter. And notice that I could start at -4, but I could also say, let's go ahead and ask me what x's I want. So now I've highlighted ask x and hit OK. This is going to give me a blank group, but I can put in -4, and that tells me the -1 that we got before. That's the same number, telling us this is at -4, -1. All right, so my vertex, here's my -4, here's my -1. I'm going to go up -3, -2, and down -5, -6. And to generate that on my calculator, okay, notice it's asking, what x do you want? Well, I'm going to tell it -3, and that's going to give me an answer of -2. And then I'm going to try again and say, okay, what about -2? And it's going to say -5. This should be symmetric over the vertex, so let's double check that. If I plug in -5, I'm expecting a -2 here, and that's what I got, -2. When I plug in -6, I'm expecting -5. That's what we got. So we're seeing that symmetry. So really we only have to plug in these two, and then we have the other side. That's what the axis of symmetry is doing for us. So let's go ahead and plot these. We have -4 on x, 1, 2, 3, 4, -1 on y. We have -3, -2, so -3, 1, 2, 3, -2. Symmetry over the vertex here. And -2, 1, 2, -5, 1, 2, 3, 4, 5. Axis of symmetry, pop over here. And now we have drawn in, ooh, I kind of missed there. Draw in our parabola. I want to be able to see your points more so than your curve. I wanted to make sure it doesn't look like this when you plug it in, but as long as you get the general points there, we're going to be okay. All right, on number 4, we have y equals negative 2x squared plus 4x plus 1. All right, so now I have a negative 2, so that's going to open down again, giving me a maximum. Axis of symmetry, excuse me, opposite of b, so negative 4 over 2 times a. Negative 4 divided by negative 4 is 1, so we get an axis of symmetry of x equals 1. Plug in to find y. Negative 2, there's an x, put it in parentheses. Plus 4, put in an x in parentheses, plus 1. So, again, we're learning how to use our calculator a couple different ways. Negative 2, 1 squared, plus 4 times 1 plus 1 gives us a y value of 3. So my vertex is going to be at 1, 3. Here's my vertex. I put it right in the middle. It's going to be symmetric. Here's my 2 other points I need. Count up, 2, 3, count down, 0, negative 1. Once we generate this, now let's put our calculator to work and find those other pairs for us. What our calculator is doing is plugging those in just like we do for the vertex. I typically plug in for the vertex and then I go to my calculator. All right, so we have negative 2x squared plus 4x plus 1. Plug it in. Hit enter. This time I'm going to say let's start at 1 because that's where my vertex is. And I'm just going to have it auto-generate. I kind of like that, making me a list for me. Because there's my 1, negative 5. So that's the 2, that's the 3. I get my 1, negative 5, and this should be 1, negative 5 as well if I were to look at it going the opposite direction. There's 0 at 1. There's negative 1 at negative 5. All right, so now I'm ready to plot my graph. I'm going to go over 1 on x and up 3 on y. It should be opening down, so the next point I'm going to go over 2, up 1. Okay, and then I'm going to go over 3, 1, 2, 3, and now down 5. 1, 2, 3, 4, 5. Now there's this symmetry over this line here, so I can plot on the other side. There's the 0, 1, and 1, 2 here, so 1, 2 on this side. There's my negative 1, negative 5. And this one's a little bit skinnier here, and we'll talk about why that got a little skinnier. Man, I feel like mine are pretty shaky, wiggly. I'm going to try that again, see if I can make that smoother. Nope, I think I'm just wiggly today. All right, you can see my 5 points that correspond. I've graphed them correctly, even if I'm a little wiggly. All right, on number 5, we have y equals x squared minus 6x plus 11. All right, I'm going to put my 1 in here, telling me it opens up, giving me a minimum. So those two always go together. As soon as I have up, it's going to be a minimum at the bottom. X equals, let's find that axis of symmetry. So x equals opposite of b, so that's a positive 6 out of 2 times a. So 6 divided by 2 is 3. And then I'm going to find my y by plugging in. Anywhere I have parentheses or an x, I put parentheses and replace it with 3. All right, to my calculator to find this value. So I have 3 squared. Oop, let's get out of there. Clear, clear, clear. 3 squared minus 6, replace x with 3 plus 11. And I get 2. All right, so because this equals 2, that's the other part of my vertex. 3, 2 for my vertex. Over 3, up 2. All right, so then I'm going to generate my list. Go up 1, go down 1, 2. And go to my table. All right, we'll go to table, clear that guy out. Let's put the new one in. X squared minus 6x plus 11. And enter. I'm going to have it start at 3 for my vertex. and I'm okay with it auto-generating because I already know I'm going to pick 4 and 5, so that's 3 and 6. So by now, hopefully you believe me that this will match the 3 and 6 here as well. And now I'm ready to plot. 1, 2, 3, up 2. 4, 3, so I'm going to go over 1, 2, 3, 4, and up 3, 1, 2, 3. Axis of symmetry says this should be over 2, up 3. That's that axis of symmetry saying they have to match. 5, 6, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So now I've got this point. Axis of symmetry will match over here. That's the 1, 6, giving me my parabola that opens up, giving me a minimum value over this axis of symmetry with vertex of 3, 2. All right, on number 6, our last one today. Hopefully we're seeing this pattern using our calculator well. We have y equals 2x squared plus 8x. Notice that there's no c here, so as my reminder, I'm just going to put plus 0. I have a positive a, so that opens up, giving me a minimum. I want to find the axis of symmetry, so what does x equal? Opposite of b over 2 times a. All right, so now we have negative 8 divided by 4, which is negative 2. And then let's find y. So y we're going to say is equal to 2, negative 2x squared plus 8, x is negative 2, and plus 0. There's no c value there. So in my calculator, I'm going to clear out my table here and go just exactly as I see it. And plus 0, even though I know it's not going to change anything, we get negative 8. So we have negative 2, negative 8. All right, so looking at my calculator here, we're going to put in our vertex, negative 2, whoops, negative 2 here, negative 8. All right, so negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. It opens up, so this will stay on my graph, and I'm going to put this in my calculator to generate numbers that are above negative 2 and below negative 2. All right, so table, clear that out. Let's start with a new table at 2x squared plus 8x. I'm going to start at negative 2 where my vertex is, step by 1, and it'll generate it for us. There's our negative 1 at negative 6, and our 0 was at 0. Hey, so it goes to 0, 0. So now at negative 1, I'm going to go 1, 2, 3, 4, 5, 6. There's this one. So this should match on the other side. Negative 3, 1, 2, 3. Here's my negative 6. And I can plot 0, 0, which should match on the other side. Negative 4, 0. 1, 2, 3, 4. You guys, I had my plot point in the wrong spot. Let me fix it. Something was off. It went too far over there. All right, so now we have this kind of skinny graph here. Boy, let's try again. Maybe if I come from this direction. Okay, skinny, skinny. And coming down, going to this other side here. Oh, okay. Again, I can see my 5 points here that I've plotted from my table here. So that's where I'm kind of looking for it. The curve we want to know isn't V-shaped, that it's U-shaped. Let me know if you have any questions, especially using your calculator. That's going to be a key part this unit.